Hello all. In this tutorial, I will show you how to do the Monte Carlo simulation for the different parameters of operation amplifier or any other circuit. So here, as an example, I am taking 4 different test benches which I have simulated so far, showing you how to do that. So the first is the open loop gain setup. So in this case, I would like to do the Monte Carlo analysis so that I can see the impact of the variation of devices or model parameters on the gain, open loop gain, the phase margin, the bandwidth, and the UGB. And in the common mode setup, also I will see the impact on the CMRR, and then I would also see the impact of these statistical variations on the slew rate and also on the total harmonic distortion. So let's go to ADL. So basically what I had done so far here is these are all the simulations which I have been showing in the previous videos. So I just compiled them together here, and now so far you can see here I have the bandwidth, the UGB, and the phase margin, the power consumption, slew rate, and THD. They are defined from the calculator, so they are already defined. But to see the impact of statistical variations of device and model parameters on my open loop gain, I need to define this parameter in the calculator. So if I do, for example, not right now, so what if I just simulate it one time here first? So you see here it's a plot, so I cannot achieve the Monte Carlo impact of the Monte Carlo simulation for the AC gain or for the CMRR or for the AC phase. So what I would like to have, I would like to have this gain here for the 72 dB. So I'd like to display it by a calculator, just this number here, and similarly for CMRR. Then I'll go to the Monte Carlo simulations. Okay, so for now let's do one thing. I will send this to calculator, and so here I go the functions. There is this function called value. So I will keep at 100 hertz. Let's say the value of the AC gain. So it's, let's see what is the value here. So it's around 72 dBs. So I will send this to the ADL window. Similarly, I will send the CMRR response to the calculator, and here I will again take the value. You can also take it 110 here, to be more accurate, but I think 100 hertz also it is the same CMRR response. There's not much impact on the CMRR or on the AC gain also. So I'm just keeping it as it is here, and let me see that. So CMRR is around 100 dB. So I will also send this to the ADL window. So now here, let me close this and let me go back to this ADL window here. So let's give it like I'll keep it gain, okay, apply, and this I will keep CMRR, okay, and because for the Monte Carlo I don't need these waves, so I will just unselect them. I don't want to plot them, okay. And this from the AC phase, I just need the phase margin which is already defined here. So let's simulate it just once again. So far I'm doing the normal simulation. I'm not doing any Monte Carlo. I just want to see I have all the values here. Okay, perfect. So these are the values what you see here. They are the values at the typical. I did not define any Monte Carlo or something. Now let's go to the Monte Carlo simulations. So before actually doing the Monte Carlo simulation, you need to define the model library, which contains the models which could predict the statistical variations, from the device and the model parameters. So when you use these model libraries for the Monte Carlo simulation, it allows you to predict, how the impact of the mismatch or the process variation is going to affect on a single chip or a wafer, between different devices. So let's go here. I can go to the setup model libraries, or I'm here as model libraries, and here if you see here, you have the different corners here: nominal, slow, fast, slow, fast. So for the Monte Carlo, I keep it statistical here. Okay, so generally it should be nominal for the normal simulations, but when you do a Monte Carlo, you need to define the Monte Carlo model library here. Okay, so this is for the GPDK, but if you are working in a TSMC or a UMC technology, so you might find a Monte Carlo folder in your models in your technology folder, or it will be with the .mc. So you need to find that and define it here. And once you define it here, just press OK. Then the next step is to launch the ADXL. So either you can launch it from here, or you can go to here in the schematic and go to launch an ADXL. But let me try do it from here. Okay, so I will go here, launch ADXL. So I will create a new one. Okay, and it's asking me the names. I keep as it is here, nothing change. So I don't need to define much what is ADXL, because the description is written here. When you launch the ADXL first time, you will be getting the features, what is ADXL and why it's used and all this stuff. So now when I launch the ADXL from ADL window, I get by default all these parameters here. Okay, so this is one way you can work on the ADXL. Okay, but let's try another one. I will just okay, let me first cancel it. Let me first save this state here, what I did here. So I will just save this. Okay, yes, and I will close this. So basically I will also close this. I don't want to save it. So now let me go to again back to schematic here. So I had the saved state ADLs. Okay, and I go here, launch ADXL. I create a new one, and now yeah, everything as it is. So here, this is what I was talking about. You have all the description what ADXL is about. Yeah. Now, first of all, you need to define the test, which test you want to do and all those things. So you click here and click to add test. And then the OPAMP Monte Carlo, this window here, okay. And this window will pop up, the ADL window basically. So here, now I will load a state, which I had saved earlier. So when I load the state here, you see here, it's the same one which I was showing you earlier. And one more thing is I need to make sure here the model is defined as Monte Carlo here. Okay, just cross check it. Now it's fine here. So now let's go to the Monte Carlo simulation. So I'll go here, I select the Monte Carlo sampling here, and click on this window next to it. So what I want, as I said, in Monte Carlo simulation, we do statistical variation and uh, of device and model parameters to see the impact of process variation and mismatch variation between NMOS, NMOS, or PMOS, PMOS, something like this in a single wafer on a chip. So here I will say both process and mismatch, and yeah, keep as it is, number of points. So this number of points is basically here. For example, we are trying to fabricate a same design 100 times, or let's say 200 times or 300 times. Then we want to predict how many of them will give us the optimal performance what we are expecting and all things. Or let's say out of, for example, here, if I take 100 samples, I would like to predict out of 100 chips or out of 100 amplifiers, how many amplifiers will give me the required specification which I want. Uh, Something like this. Okay, and yeah, you can save also this mismatch data and process data for further processing or further understanding everything. But let's keep as it is right now. And so here there is option, this specify instances, devices not specified. If you want to exclude, include some devices which you don't want for the Monte Carlo and all those, you can define it here. But for now, let's keep everything as it is, and I will press OK. So I took an example here, 100 points, but typically, I mean, you should take more. You can go till 500 also, 1000 also. But just for the testing purpose, I take 100 here, and I will OK it, and then I will run it. Okay. So when I simulate it here, you will see here the Monte Carlo 0.0, it's running, and you will also see here the different information which you get from Monte Carlo simulation. We can also see it in a graphical way at the end of the simulation. So again, just repeating, when we do Monte Carlo simulation, it just gives us an idea, how our chip is going to behave, or you can say what is going to be the impact of the manufacturing or process variation and the mismatch, between devices in a single chip or wafer, something like this. So the model file which I showed you, it has some kind of statistical model which can predict, which gives you an idea how it's going to be when you actually fabricate the amplifier. So here, as you see here, I defined all those in the calculator, then I can display it. If you use the waveform, which was there like AC response, you won't get any number here because it's a waveform, so you don't get any Monte Carlo. So remember, whenever you want to do a Monte Carlo simulation, you need to define that in the calculator. You can also, like a lot of times people ask me, I want to see the Monte Carlo simulation for the threshold of a device, something like this. So you can similarly go to, if you are very well aware of how to use the calculator, you can go to this opt option there, and I hope I can launch it here just for showing you. Yeah. So here, yeah, dot opt, you can take it and then select the transistor. You can display the VTH of them and then, yeah, send it to ADL, then do the Monte Carlo simulation or some other, device parameters or something like this you want. So let's wait for a moment. Right now we are around 60. So once it finished, then we'll see the impact of the mismatch on our different parameters here. So typically it should follow a Gaussian curve, and most of the samples out of 100, let's say the majority of the samples, if they lie in the middle of the Gaussian curve, that means we are good to go for design, because we believe from the statistical model that most of the amplifiers they are going to work. So if majority of them they are not in the middle of the Gaussian curve, that means we need to do some, again, go back to the design and do some optimizations. Okay, we are almost there. 95. So now it's finished. So here I go here, I just plot all. Okay, so when I plot all, you will see all those parameters getting plotted here in this way. So the first one you see here, it's the bandwidth, and then the UGF, then the phase margin, and similarly the power consumption, the slew rate, the THD, the gain, and the CMRR. So you see here most of them, as you can see here, they lie in the middle. For example, the gain, the CMRR. Let me send again to the new window. We can see it here more clearly then. No? Okay. It should be. Okay, somehow it's not getting copied here, but let me check it here. So you can see here most of them they are lying in the middle of the Gaussian curve. So this is how you do the Monte Carlo analysis of any circuit in general or for an amplifier. Thank you.